Now let's discuss the energy band diagram of two closely spaced atoms. Here we can see there are two energy band diagrams for two different atoms which are closely spaced. But in this situation the separation between the two atoms is so large that energy of one electron in one atom is not affected by the other. That's why both of these curves are rectangular hyperbolas, because these are almost in the influence of their individual nuclei, which is located at the center. So here y-axis is representing the potential energy, and on x-axis we are talking about the distance of electron from the center. And here these dotted lines are representing the energy levels for the orbitals 1s, 2s, 2p and 3s respectively. Now let's see what happens when the two atoms are brought close to each other. Here we can see that when these atoms are getting close after, the separation decreases below a specific value. Here we can see that overlapping of orbitals between the two atoms will start. And as separation decreases, overlapping increases. At this situation we can say that the two atoms are at such a separation where the 3s orbital will overlap in this zone, and 2p to s are in the influence of their individual nuclei only. So here we can state, in this situation the electron which exists in 3s orbital is free to move in the whole combined 3s orbital, or we can say this is the molecular orbital in which there is a common orbital in which electron is allowed to move, but the electron which is moving in the influence of an individual atom, that is in 2p and 2s, is not allowed to move in the other atom zone. But those electrons which exist in the orbital 3s or any orbital above this, say if 3s is in the overlapping region, all other orbitals which are in their zone above 3s can also be considered as these electrons which are allowed to move in both of these atoms. So we can see this is the point x, where the two atoms' potential energy is getting equal, is exactly at the midway of all the orbitals which are above this point x, or where potential energy is more than this x value. We can say that electrons are free to move in any of these orbitals, or the orbitals will combine and form a common orbital. This is the basis we are going to use to understand how orbital structure exists in case of a solid lattice structure. We will continue it in next section. In continuation to this we will see a realistic situation also. When two atoms are brought close to each other, here we can see there are two atoms. And when these are brought close to each other, initially, they are having their electron cloud associated with the individual nuclei. And when these are getting close to each other, when their electron cloud, outer zone, of this electron cloud starts getting overlapped, we can say a common cloud will be there in the outer zone of these two nuclei, and in the inner zone we can see that electrons in the lower orbital, like which we have seen in the above figure, 1s, 2s or 2p, which are not getting overlapped, are associated with the individual nuclei. And the outer orbital in the above figure, like 3s and above and all other above orbitals which are getting overlapped, will form a common orbital cloud. So this is the situation which we can realize in practice. Just keep it in mind for imagination, like whenever atoms get close. The upper diagram shows the energy band diagram of two closely spaced atoms, and this lower figure gives us the three-dimensional idea about How the electron cloud sharing takes place, or due to overlapping a common cloud is formed, which we term as molecular orbital.